All right, thank you so much for joining us this afternoon. Sorry we're a minute late. We were just making sure we had everything working for you guys. My name is Katie Schauer, and I am the digital marketing specialist here at InSource. I will be your host for the event this afternoon. And just a few housekeeping items before we get started. We are recording today's session and we will be posting that to our website later next week. You will also receive a follow-up email with links to the recording. If you have any questions at any time during the presentations, please feel free to use the Q&A or chat boxes to ask any questions you do have, and we will answer those at the end of the session. Right before we do our Q&A session, we will have a short poll just to gauge how you enjoyed today's topic and to learn more about if you plan to attend our future lunch and learns. With that, at this time, I would like to pass it over to Aaron Evans.
Thank you, Katie, and good afternoon, everyone, and welcome to our Digital Lunch and Learn series. This session is just some knowledge transfer events that we're doing. Of course, we would like to do these in person, but we can't, so we're bringing it to you digitally. In case you didn't attend the previous sessions, in our first session, we covered what was new from AVEVA. We talked about how AVEVA is driving digitization from edge to enterprise, including a lot of information on some new and exciting offerings from AVEVA with the 2020 release of InTouch system platform and their cloud offering. Our second session, then we talked about some of the other offerings that AVEVA has beyond the HMI SCADA offering. So we talked about manufacturing execution systems and their asset performance management offering and what we call the unified digital engineering offering from AVEVA. Third session then focused on taking a deeper dive into the AVEVA asset performance management portfolio, and we learned a lot about the exciting predictive analytics tools that's available. And then that was what we did last week. So today, we're now going to focus on edge solutions that are being offered from InSource. And these solutions are some things that are built by InSource, but also are offerings from our partners like AVEVA, Stratus, and Advantech. And after our session today, there are 3 more sessions that you will want to consider. And so next week, we're going to be talking about the unified development portfolio and taking a deeper dive into 3D laser scanning, which is a real exciting technology. That will be followed by mobile computing capabilities that support paper on glass, workforce optimization type solutions. So you'll want to see that as well. And then we're going to finish this up with a session that's talking about best practices in building a solid IT infrastructure to support your client's edge enterprise solutions. And these are things like PCs, thin client network, fault-tolerant servers, video, and enclosures. So you'll want to come and wrap up that with us to learn more about those offerings as well. So with that, I am going to turn this over to Ted Floor, who's going to kind of give you this, kick the day off and talk about the Edge offerings. Ted?
Thank you, Aaron. So Aaron mentioned in his first discussion there something called Edge Enterprise. So at InSource and AVEVA, we've embraced that whole concept. You know, we've had a lot of HMI systems out there for years, but you know, the big buzzword these days is edge computing. And what's that really mean? Is we want to do some computing, you know, at the edge, down by the actual piece of equipment. You know, that could be a blind piece of equipment out there or a headless device that's feeding data up to the cloud, or it could be, you know, a full-blown HMI where you actually have to do some local control. So we have options to be able to do that. We have something called AVEVA Edge that will allow us to have that local control, but it's also could be used to push data up to the other areas. So, you know, in the control room, for example, we could have system platform or InTouch, and that's connecting to these edge devices to be able to, you know, have the operators in the control room control the entire operations. You know, down here at the edge, we're probably concerned with a piece of equipment or, you know, a specific machine that we need to have that local control. So we have solutions that can, you know, work down at the edge from an HMI perspective and use that to pass data, say, up to our system platform environment in the operations control room. And then from there, we have the ability to push data up to our cloud historians or other historians, so that, you know, on the corporate side or the operations side, we have the ability to have reports and dashboards and those types of things. You know, we even have some cloud development tools that we can develop our solutions in the cloud and push that development, those projects down to the edge and down to our individual projects, if you will. And then, you know, we have connections to the enterprise, our MES connectivity to, say, our business systems and our ERP systems. So, you know, that's the big vision here of the edge to enterprise. We can get down to the small sensors on the plant floor, connect to those devices, and pass that information up through the operations centers all the way up to, you know, the corporate environment to get more visibility into what's going on in your processes. So if we take this one step further, you know, if we look at a remote SCADA application, another location where we could use the edge application, where we need some local control, may need the local HMI, and then have the ability to push that data back to a central control room to monitor these remote assets. And that might be a system platform implementation that you have in your unified operations center, collecting data from all these different remote assets. But what's unique about this is, you know, we can have an AVEVA Edge out there, have a local HMI screen, but it can use something called MQTT Sparkplug, which is Sparkplug is a new standard on top of base MQTT for the industrial world. But these protocols are very light, right? So a lot of these remote stations are connected via cellular modems and things like that. So bandwidth is at a premium. So we don't want to be constantly pulling those devices out there from our standard driver set. MQTT has the ability to push data to a broker upon the data changing, so it's going to save some bandwidth, and then we can subscribe to that data from, say, our system platforms or from our InTouch application to be able to see that information in our central database, and so our central control room, if you will. So, you know, this is a great slide, but I like this slide a lot better. Those slides were marketing slides, and they tell a great story, but this is a slide of a project we're actually doing with a customer, an oil and gas application, and we're putting in AVEVA Edge out there. They need some local control to control this well pad connected to a Rockwell PLC, but they also want to share information back to their central control room. They've been a system platform user for years, and now they're going to tie into all these different well pads, could be 100 of these things. So they needed something cost effective out there on the well pad, and something that had the ability to push data up to their system platform environment and unified operations center, and then potentially push that data up to AVEVA Insight and Cloud. So they're using AVEVA Insight in the cloud for all their midstream data, but now we're going to take this edge data from this well pad, you know, a lower cost solution than, say, a full-blown system platform, gives them that local control. AVEVA Edge has all the drivers that talk to the local PLCs, gives them that graphics, and they also have the ability to, they have another division that wants to take some of that data and push it up to their own proprietary system. So through this AVEVA Edge application, we have the ability to push data via MQTT up to this other system. So this fit really well for this customer, where they're in the process of developing this right now. They have a couple well pads online. They're in the process of getting it connected to their system platform. And it's going to be a great solution for them, so they can kind of roll these things out, cookie cutter these things out, and roll them out to many different well sites. So what's coming in this arena is, we're not using this yet, but what's coming is the ability to have this thing called AVEVA Connect here, and we can do some development for these edge solutions in the AVEVA Online Integration Studio. And these edge devices out here subscribe to AVEVA Connect. So when we want to make a change from our master development station here, we can make a change, push that change to the cloud here, and all these remote sites have a little bot on there listening for new changes, and they'll connect to AVEVA Connect and download the new version. So someone doesn't have to go out there and drive to these different sites to upgrade the application and upgrade what's going on with these remote sites. They all can be managed from the cloud, from the Online Integration Studio and AVEVA Connect, to be able to update these locations out there at the remote locations. So with that, we need to have hardware for all these edge devices to run on. And our partner Advantech has a lot of the different hardware devices that we need. Kevin's going to be talking about some remote I/O that we have. They have remote I/O devices that we can use to connect these stranded assets and bring them into our systems. They have standard panel PCs that we have out here, cellular modems. So there's a whole line of products that can be complementary for this edge solutions that we have to be able to go connect to all these different devices and bring that data to your fingertips. So with that, I'm going to pass it over to you, Rufus, to drive a little deeper into AVEVA Edge.
Okay, hopefully everybody can hear me. All right.
Yep, I'm trying to get it past you.
Turn my on.
Yeah, I can hear you, Rufus, and you should have it. Yep, you're good. Okay. Sorry, I was having an issue.
Not a problem. Not a problem. Thanks everybody for showing up today. Let me introduce myself. My name is Rufus Hanson. I'm along with Ted. I'm one of the systems consultants here at InSource. And what I'm going to do is I'm going to piggyback on what Ted is talking about as far as in terms of using the AVEVA Edge HMI software. Now, first off, I'm going to just kind of show you some PowerPoint slides, mainly just to focus your attention on some of the key features and the value of using the AVEVA Edge software. And one of the main benefits of using the software, or some of the main benefits, is its portability, mobility, and interoperability. Portability meaning it not only can run on a standard Windows-based platform, but also Windows IoT platform, as well as the traditional platforms, well, I won't say traditional, let's say legacy platforms like Windows Embedded, Compact Editions, what we used to call Windows CE. Also, it runs on a Linux-based platform as well. But when we talk about Linux, we're mainly focusing on something like a Raspberry Pi. All right, so that gives you the idea of its portability. Mobility-wise, it can be run on desktop operating system, panel PCs. As Ted pointed out, we partner with Advantech. They do have panel PCs and panel-mounted systems that will allow you to run the software there. Also, with the new age of bring your own device, you can also run this platform, run the software on platforms like tablets, Android tablets, iPhones, and so forth, as long as they have HTML5 based browsers. Now, when we talk about interoperability, we're talking about connecting to the field, not only connecting to traditional devices like PLCs, robots, and such, but you're also able to connect to third-party databases, okay, and using some of the modern protocols for industrial Internet of Things, or IoT, such as MQTT, and I'm going to demonstrate that later on. Now, what is the value? What is the true value of this software? Well, for one thing, it's easy to use. It's powerful. Just because it's InTouch Edge HMI and it's an affordable package, don't think for a minute that this is not a full-blown HMI system. It is. This HMI package can do everything from allowing you to develop MES applications, full-blown packaging systems, HMI systems. It can connect to third-party ERP systems and the like. And one of the main value propositions of the software is the fact that you can develop the project in one place and run it virtually anywhere. Again, as you see on the bottom here, Linux, Windows CE, Windows Embedded, Windows Desktop, and among others. The idea here is flexibility. I can develop it in one place and run it across my enterprise, okay, and run it on a variety of systems. And I can take advantage of some of the newer based technologies, again, like tablets, iPhones, and even if I want to go the less expensive route of running a Raspberry Pi, I can do so. Now, this software has been around for a long time, since 1997. And what this shows is it's progressed over the years, as you can see, up to, this slide says 2019, but in 2020, there's another version that is just about to be released. Okay, it's already been developed. It's just about to be released, And it will be taking it, not only will it be taking advantage of all the operating systems that you can run on now, but will also integrate more with system platform and utilizing what we call industrial graphics. Ted pointed out earlier that, you know, with the AVEVA Connects, you can do your development in the cloud, okay, and push that developed software, the runtime versions of it, out to your enterprise. So it gives you a lot more flexibility as well. Again, taking advantage, okay, of the newer, the latest and greatest technologies. Now, this particular software, as you see, as this screen shows you, we're in all kinds of industries across the board, everything from oil and gas, automotive, instrumentation, warehousing, water, wastewater, machinery, pharmaceutical, and others. So this software is not just geared for one particular market, okay? You know, you can do things like just create regular HMIs. You can focus on supply chain management, database integration. It has a fully functional web-based solution, and it's IoT or IIoT ready out of the box. Some of the main features here. When we talk about abstraction, you know, sometimes when we're dealing with HMI, sometimes we have to go outside of the HMI to get drivers. Sometimes we have to get some type of third-party application to connect to other databases. You know, we have a limitation on the hardware platforms that we can run on, or, you know, when we want to expand the system, you know, we have to go outside of the box, so to speak, in order to like get APIs or some type of, you know, some type of expandability, okay, so that we can connect to other third-party applications. Well, what they're talking about here with these layers of extraction and in this modular architecture, the communication drivers are already built in, okay? You're going to see later that we have well over 240 drivers out of the box. We have the capability of connecting to external databases out of the box, okay? As you saw previously, we could run on all kinds of platforms, even Linux, okay? And as far as these proprietary APIs, if you know how to do .NET programming, okay, if you're an SI and you have, you know, your power users and you can do your own development, you can develop your own APIs, okay, you can also incorporate your proprietary code inside of the software natively. And we already focused on the portability aspect of it, but this just kind of drives the point home. You can develop the software in one location and take advantage of all the existing technologies out there to deploy your content. Everything from a full version, a full SCADA runtime, which runs on Windows 10 all the way up to, or Windows 8 or Windows 7, all the way up to Windows 2016. Okay, so the idea here is we're not leaving anybody behind. Also, you can, as far as the runtime versions of it, you have a full-featured HMI, you know, through an embedded view, like using technologies like Windows Embedded Standard Edition, Windows IoT, and Windows Embedded 8. And also, for those that are still dealing with Compact Edition or Windows CE, we also offer that as well. And as I said before, we do have Linux, or the capability of running it on a Linux system through an HTML5-based browser. From a mobility standpoint, we offer you 3 different ways of getting that information out there. Something called Studio Mobile Access, or SMA, where the platform is agnostic. Essentially, as long as you got an HTML5 browser, we can send you the information, or you can display the runtime information. Then we have the Secure Viewer Thin Clients. The key thing here, it runs on a Windows platform, and it takes advantage of Windows technologies like ActiveX. And we also have Web Thin Clients that also takes advantage of ActiveX. In terms of interoperability, we can connect to virtually anything, okay? Everything from the traditional, you know, PLCs, as you can see here, Schneider Electric, Allen Bradley, Siemens, Modbus, Profibus devices.
It sounds like we have lost Rufus's audio. I apologize for that. Hold on one moment. All right, I'm going to switch us over to Kevin Modlin for the moment until I can get Rufus back online. I do apologize for that. Okay, Kevin, you're ready to go.
Excellent. Well, thank you, Katie, and thanks to Rufus if you're still hearing us for the interesting info about Edge. Again, my name is Kevin Modlin. So this whole today's focus is Edge offerings. I'm going to switch gears a little bit and talk to you about some things that InSource has put together as packaged offerings. So what do I mean? I mean things that make it frictionless. So that's a term you're going to hear from me throughout this presentation. Things that make it frictionless for customers to deploy some of the tools that you've been hearing about before. So we call this frictionless IoT for industry, and the name we put on these things is XO solutions. So think of XO as potentially 4.0 or 5.0 or whatever is next. So we've branded these things as InSource XO solutions. And I'm going to dive into 3 different offerings. So I'm going to dive into what we call XO Historian and XO Downtime and XO Health. So those are the 3 things we're going to cover today. Historian and Downtime are built with AVEVA Insight as the backbone of those things. So we'll take a quick dive into what that is. And then XO Health is built with a tool called AVEVA System Monitor. It's also known as Sentinel. So our packaged offering in every case depends on some AVEVA backbone components. And I mentioned frictionless. I wanted to spend a couple of seconds at least talking about what are the kinds of things that cause friction in the deployment of automation systems. So first and foremost probably is the effort or cost of implementing these kinds of things, or the burden of owning and maintaining the system. For some systems, there can be some friction in the fact that PLC data is inconsistent from one system to another. So for a customer who had a production line implemented in 1984 and a separate one implemented in 1994 and a third one implemented in 2017, the kind of data in those different vintages of PLCs might be inconsistent. And then there's a need for hardware. So some customers have the kind of staff who can support these things, and other customers maybe not. And to a greater degree these days than ever, the number of available resources to support automation systems is trending down. So we think we have some tools to help with that. So let's dive into the 3 offerings and talk about explicitly what they are. So XO Historian is a cloud historian, and I mentioned before the backbone is AVEVA Insight. And I would say that the target for this offering is companies that have low to moderate automation infrastructure and maybe no historian, or perhaps it's a company that has a full-fledged modern automation stack but want access to process history information from outside the plant. So think of those as potential targets for this XO Historian offering. And let me switch gears and show you what this is. So I've got a browser here. I've got Chrome connected to online.wonderware.com, and I want to go straight into something that is that you might not think of off the top of your head as historian functionality. I want you to focus on this right-hand column in the area that we call the news feed. So let me scroll down here and find something that's representative. All right, so this area here, I should make this says that well 2 outlet flow was lower than usual. And so what you see in the trend of data here is that there's some red dots, and that's the data that the system thinks is inside the expected range. And then there are some red dots down here, which is data that the system thinks are outside the expected range. And the beauty of this is that this is unsupervised machine learning, meaning nobody had to go build a model of this outlet flow for the system to evaluate. This takes advantage of the fact that if you feed enough data into the system, and enough means generally a few weeks worth of data, the system can begin to recognize what normal looks like and then once it recognizes what normal looks like, it can highlight to you things that seem like they're abnormal. So don't think of this as a sophisticated predictive analytics program, because it's not what it is, but this is unsupervised machine learning. And the beauty is you don't do anything to get these newsfeed alerts. They just happen because the system is paying attention to the data you're feeding it. You can tune these alerts to some degree. There's a thumbs up, thumbs down here that the system will take into account. If you say this isn't useful to me, then you're less likely to see this in the future. If you say this is useful to me, you're more likely to see this kind of alert. And the newsfeed can support things like data is higher or normal or lower than normal. It can support things like variability. It's more variable or less variable than normal. And it can support multivariable analysis. So if two tags normally trend together, but they started trending apart from one another, the system can highlight that as well. So it's an interesting adder. It comes along for free, air quotes here. It comes along for the ride. You get this as a part of the historian in the cloud. And then other kinds of things you can do with this. Let me switch to a dashboard view to give you a sense for the kind of presentation styles you can have. So in the upper left of this view of the world is a map. So this might not be relevant for a single building manufacturing site, but if you're a water wastewater facility, then being able to plot values on a map might be useful. And if we go down to the bottom right corner here, you can see that we have the ability to add custom graphics and layer process values on top of those custom graphics. So we get different tools for different presentation styles. And if I drill into this area in the middle where we've got some trend lines, let me switch gears here and put this on a line chart. And this is pretty busy. It's got too much data on it. So I'm going to take some of these tags off. I'll just manually click and take a few of these off just to make it a little easier to see. And you can see I've got a scooter along the bottom here. This is showing me today. So this is starting at midnight to now. Let me shrink that down to 1 hour. So now I've got a 1 hour trend. And as you're probably accustomed to seeing in historian type tools, I've got a scooter that tells me what the value is everywhere along here. I can add comments. So I can say I want to add a comment about what was going on in this location. That gets saved to my cloud area. And this little bell allows me to add an alert. So I can configure the cloud system to alert me if a level goes above a threshold or that level goes below a threshold. So some pretty sophisticated things I can do here. And then finally, I can also export this data. So if I click this button in the lower right-hand corner, I get a pop-up here to download this either as a CSV or to Excel online. So that's a quick drive-by of what AVEVA's Cloud Historian offers, but what do we offer on top of that? Well, what our XO Historian offering includes is obviously a subscription to the Cloud Historian, but also the hardware and the application to connect to your existing control layer and push that data up to the cloud. So we provide, configure, and manage all of the infrastructure that's required here. So we provide the hardware, we provide the software that's on it, we configure it, we own that, and all of that is provided as a bundle to the customer in a single subscription. So anybody can go buy the AVEVA Insight Web Historian as a subscription. What we're bundling on top of that is the hardware and configuration services and the maintenance of that hardware over time. So that's an adder. And if we try to map this against the things that I said are friction points before, we can address the effort and cost of implementation because these things are surprisingly affordable. We can address the burden of system ownership and the need for hardware because we own it, we provide it, we maintain it. If it breaks, we replace it. So that's what XO Historian is, big picture. XO Downtime is an extension of that same thing, but it's a cloud platform that allows you to do downtime, OEE, and production reporting kinds of things. And I'd say the sweet spot for this is companies maybe even as low as no automation infrastructure. We'll talk about that in a moment, but certainly no automation, maybe up to moderate, or a company that wants a lighter OEE solution than what you might get as a full-fledged on-site MES solution.
So let's take a quick peek at what that looks like. So if I switch gears back to the same interface where we were at before, switch gears over here to the equipment efficiency area. I'm currently looking at filler 2, and let me do a little bit of a zoom here so we can fit more of this on the screen. So interesting things that you see in this interface now is you see this in the upper right-hand corner, you see the current OEE, and you see this chronology of events. So right now, this is tuned for the last hour. So we're seeing the events for this filler for the last hour. And we see some KPI kind of information. So we see downtime reasons Paretoed by count, and we see downtimes Paretoed by duration. And then down in the lower right-hand corner, we see a summary of the time for this hour. So 54% was runtime, 36% was downtime, and 10% was idle for this 1 hour period that we're looking at. And directly in this interface, if I wanted to add some additional context to this e-stop, I can edit this event and pick a different reason. I could say, well, this was really a planned changeover event, not really. The e-stop was what we used to stop the machine, and maybe that wasn't smart, but we can add comments and change the root cause that's assigned to this downtime. We can also split and merge events. So a quick, simple snapshot view, and the slider lets me change my view of the world. So I was looking at an hour, and now I'm looking at 4, or I can look at the current shift, or I can look at the current run. So the current run would be, when did we start this work order? And I can see that was at 8:22 this morning. So this is a little over 4 hours worth of data. But if we switch gears to a slightly different view of the world, if we go drill into OEE as opposed to just specific machine events, and I'm going to dig into this case packer details. So if I click this, I get the pop-up. Click the little grid. That takes me to an hour-by-hour summary of the OEE for this case packer. And again, I can tune that, but I'm looking at today. And switch to the details tab here. Here's a grid view of all of the information. Now, this would be an hourly summary unless sometime in that hour we changed products or we changed work orders or something like that. So it would be at most an hour. And I see for this, in this time period, I see runtime, downtime, idle duration. If I scroll over to the right, I'll see production counts. So, you know, what was my good count? What was my waste count? I see information about shift and crew. And all of this, again, is exportable. So if I hit the button down here, I can download this to a CSV. So that's AVEVA Insight downtime tracking. What is it that we add on top of that? Well, it depends. And so if for a customer that has an existing automation infrastructure that has PLCs, we might add some software layer to allow us to do a little bit of logic processing. So the OI server in this picture allows me to connect to the PLCs. App server allows me to do some logic. Historian allows me to have a buffer in my edge device that will buffer really an unlimited amount of data until the hard drive fills up. But this is a special historian. This historian only lets me get back data for a short period of time, but it lets me store it for as long as I need to. And then that's buffered and sent up to the cloud where it's stored. That's the sort of perpetual resting place for this. So that's what a typical architecture might look like. Well, let's drill into why the need for a logic engine. As I was describing before, if you have PLCs of various vintages, they might also have different programming models. So as you see here, the filler PLC might have a 1 in a discrete value when it's running, but the capper PLC might have a 0 as an integer. Well, that's the same thing. But anyway, whatever these values are, we need something to normalize those, because Insight, the cloud offering, requires this data to be more structured. It requires that the machine state be common across your various machine types. And that's what we're able to do with application server as a logic engine at the edge. So we're able to take the unstructured data that you see here on the left-hand side of the page, process that through our logic engine, and turn that into the structured data that you need to send to the cloud. And so again, that would look like this if the customer has existing automation infrastructure. But if they did not, our bundled solution allows us to bring shadow sensing with us. So you'll see this term here, shadow sensing. We can bring that with us and deploy it if the customer doesn't have that kind of infrastructure. And so that shadow sensing could be something as simple as a photo eye. It could be a simple tool that watches a stack light and tells us which light is currently lit. That can sometimes help us derive machine state. But either way, even if we bring shadow sensing, we're going to bring an edge box and whatever we require to get the amount of data we need. But most importantly, all of this is going to be provided as part of a bundle to the customer. So they're buying the hardware, the software that's running on that hardware, the subscription to the cloud, configuration services, maintenance services, all of that is bundled into an affordable subscription that the customer can choose to use for 1 year or 2 years or 10 years, whatever suits their needs. And I want to spend 30 seconds taking you through a real customer example. This customer has equipment that has PLCs on it, but they have an agreement with an OEM that makes them leery of putting their hands into the PLC. So they ask us to deploy our XO Downtime solution without touching the PLC. So what we did was, for 16 machines that make up 4 production lines, we put a photo eye at the exit of every machine. That allows us to infer the machine state. Is it running or not? It allows us to get a count of the units coming out of each of the machines. It allows us to establish whether one of the machines is bottlenecked or starved by the other machines. So we can do some pretty sophisticated analysis just from a single photo eye at the exit of the machine. That's what we were able to do for this customer. But maybe the most impressive thing is we went to that customer's site, and this says 2.5 days because that was the total time we were on site, but we were beginning to get data from this system in the first day. So we went to the site, unfold our laptops and start making things happen. And at the end of the first day, we're getting data. And so the customer's super excited because the project was quick and inexpensive, and they're getting some very valuable data out of it, including they built some custom dashboards so that they can keep tabs on what's happening on the plant floor on large TVs. So that's the second of our 3 offerings. So we talked about XO Historian, we talked about XO Downtime. XO Health is a packaged service that we offer built around Sentinel. That's undergoing a name change now. Now it's called AVEVA System Monitor. But either way, that's a very powerful tool, but it can be difficult for people who aren't in that thing every day to understand it and adopt it. So we've designed our offering to be frictionless, or at least to eliminate as much of the friction as we can. And we can provide a device to host the software if we need to do that, or we can run it on a piece of infrastructure in the customer's existing stack. And what that system does is monitor what's going on in their Wonderware infrastructure, their AVEVA infrastructure. And we offer this at 4 different service levels. So we label those things bronze, silver, gold, and platinum. And I'll give you a quick insight into what those levels are. At every level, we provide and configure and tune the software. And that's important because the monitoring software, if you're not careful, can deluge you with false positives or data that doesn't really need action right away. So we've done a lot of work around this, and we've got a configuration that we think represents the right middle ground between over alerting and under alerting, and every level gets that configuration. At the silver and above level, we do an annual system health check for the customer. So we go in, assess their current infrastructure, make some assessment about whether things are operating well or not, make recommendations about things that could be improved by looking at operating system logs and Wonderware logs and all those kinds of things. At the gold and platinum level, we will monitor the alerts that are coming out of the monitoring software. And so in no case do we take action without the customer's permission. We will alert the customer that something looks like the health is trending out of ideal state, and it's maybe something that they can take action on. So in some cases it'll be, you know, the hard drive on your historian is filling up. But in some cases, it might be something they would like us to help them solve using our tech support team. So we will alert them that there could be a problem, and then they get to choose whether they address it themselves or whether they engage our tech support team to help them address it. So that monitoring is at the gold and platinum levels. And then really platinum just means we're doing that on behalf of the customer 24 hours a day. That's the only adder for platinum above the other levels. So I spent a lot of time talking about bundled offerings that we provide to our customers, and I realize I'm talking to a group of system integrators, so you may be asking yourself, why would I care about that? Well, our primary business is in software, so we develop these offerings to help ease the friction for adopting our software products, but really we could use your help to scale these things, and we have a program that allows our SI partners to participate at whatever level you desire. So we can train you up on what our offerings are to the point where you can go deliver the services. If you want to do that, we can co-deliver with you. So you can participate in this and at whatever level you desire. And we've got a program built around this, and we're offering it to anybody really who wants to participate. If you have an interest in that, you should contact your account executive, whoever the sales rep is in your area, or Aaron Evans, who introduced this call today. My timer tells me I'm about 30 seconds over my time, so I'm going to hand it over to Muncie. So Muncie, you're up.
All right, Muncie, you're good to go. And we do, just a program note here, we do have Rufus back on the line. So once Muncie's finished, we will finish Rufus's presentation as well. Muncie, if you're talking, we can't hear you.
How about now?
Now we can hear you. Good to go.
So the mute on my screen was not affecting the mute on my phone. So apparently it didn't get linked right. I apologize for that. So my name is Muncie Slack. I'm a systems engineer with Stratus Technologies. And what I wanted to do today is go over a hardware solution that we offer to support, in some cases, and host the applications and the products that have been talked about so far. And, you know, with the Edge, there's a lot of different options out there, and Edge is talked about in a lot of different ways. And the biggest thing that we're seeing, and that we saw 2 years ago when we came out with a product called ZTC, is that there was nothing there to handle a medium-sized workload that was virtualized. And it was simple to design and easy to deploy. So if anybody knows anything about Stratus, we've always been the fault-tolerant company, and we've been able to host large environments, 4 to 40 or more virtual machines, or full enterprise class environments. But from a lower end, how do you deploy multiple applications in the Edge environment in an easy way? And so what we did was take an existing form factor with industrial PCs and workstation class components, and instead of putting Windows on it, we put Stratus Redundant Linux. And what that is, the combination of CentOS Linux and KVM, and we created our own hypervisor. And with that hypervisor, you can deploy multiple virtual machines from 1 to 4 to do the lightweight computing that is typically found in Edge environments. And so why would you want to do that? Well, For a lot of scenarios, the cloud's great for storing the data, and all the stuff you saw earlier with the analysis is super. But in some cases, you may run into situations where you don't have a great connectivity between the building and the cloud, or your internet communications may not be strong. And what you want to do is gather that data at the edge and process it and then send it upstream. That way, in the event something happens, you've at least got the data locally to make your decisions, whether it's predictive analytics or the analysis of what's coming off the production line. How do you create that or gather that data and process it and then send it back upstream? So what ZTC does is, by having built-in virtualization so that you don't need to have an IT degree in order to manage it, allows you to deploy multiple applications in a single environment that is highly resilient and high availability. From an architectural standpoint, it's 2 nodes that operates as a single node. Its availability layer and the virtualization platform cross both nodes, and then you can deploy up to 4 virtual machines anywhere you want to within the environment. The CPU and memory and disk on each node is identical, and the operating system is product built for this hardware environment. The good thing about the way we have deployed the operating system is that you only need one set of licenses because it only acts as a single platform, as opposed to typical redundant high availability solutions where you have to get licenses for each node inside the system. We only require one. Also, the fact that it's built-in virtualization from the factory, you don't have to go in and manually configure all your virtual machine replication from one side to the other. All you have to do is plug everything together, and we take care of the heavy lifting on the back end. Now, I've talked about the high availability side of this, but one of the other offerings that it has is a single node form factor. So say you need to start with just a virtualization of your environment on a small scale, and so you want to go with one node. And so you can go with the 110i single node or the 100i single node, and then down the road, you decide, I need the HA or FT for a fault-tolerant environment on the bigger one. Then all you do is get an additional node, plug them in, and check a box, and it will immediately start dumping the image from the original node onto the backup node and create that high availability platform. So it's very expandable and allows you to just combine the 2 pieces of hardware together and get a single node. And you don't have to buy any more licenses because of the way it's already set up. Now, a big reason that we started going down this path is because OT tends to not have a whole lot of IT resources. And management of those IT resources can be challenging if you're not from that world. So by us embedding the virtualization technology into the hardware and creating that redundancy on the fly, then all you have to do is set it up and your data is automatically replicated. The system resources are shared automatically. Availability levels can be matched at whatever your workload criticality is. And we can even deploy the nodes in different physical locations. Because it is 2 separate nodes and uses traditional Ethernet cabling, you can have a node at the point of manufacture in the control panel on the machine, or you can have the backup node sitting in a control room somewhere else. That way a local issue doesn't take down the entire operation. Now, as I mentioned earlier, we have both an HA and an FT mode. Most of the designs for most of the deployments are probably going to be in the HA world, but you may have like a batch or some sort of application that doesn't respond well to a failure. And so stopping it and restarting it, which is what happens in an HA world, isn't good. So there is the option on the larger system to deploy it in fault-tolerant mode. And what we do is essentially replicate the entire stack, the storage, the memory and the processing and replicate that between the two nodes. You need good bandwidth between the nodes and low latency, but that you can put one or two of those virtual machines into an FT environment, and that way if something fails, then you've got a millisecond of time where the other one gets lit up and accessed, and everything can continue to operate. So it's very flexible with whichever choice you have need to make depending on your environment. Now, because of the way this is designed, it doesn't require any specialized skills, and the repair process is very simple. We're doing the redundancy and the virtualization in an embedded fashion. So anytime one of the nodes may have a failure or an issue, all you do is unplug that node, pull it off of the DIN rail or off the shelf, depending on where you've got it deployed, put in the new replacement node, plug it in, turn it on, and it immediately starts replicating the data from the remaining node onto the new node, and will put itself back into either high availability or fault tolerant mode, and it does it without a lot of intervention. And if you look at the way a typical virtualized environment would be handled, you've got to go into, say, VMware or what have you, and install the system on the new node, get it set up, attach that node to the environment, and then put everything back where it was. If you're IT, that's fine. If you're not, it's a little bit harder challenge. Or if it's just a single node, say you've gone with a single node here, or you just got a traditional Dell PC, if something fails and you've got to rebuild from scratch, or at least dump a full image on and what takes some time. So we've automated this process to make it much quicker and allow you to get back on your feet without having a whole lot of IT intervention. Now, from a sizing standpoint, what does it look like? How would you deploy it? The 100i comes with 4 hyper-threaded Core i7 processors, and that gives you 8 vCPU. The 110i has a 6-core i7, which gives you 12 vCPU. The 100i has 32 gigs of memory. The 110 has 64. The 100i has 512 gigabytes of storage, and the 110 has 2 terabytes of storage. The reason the 110 has got more and better is because of that fault-tolerant capability. Anytime you add that replication of the entire stack, it takes more resources. So we had to build a bigger one in order to handle that type of load. Both of them still support up to 4 virtual machines. If you look at how it may be deployed, the system itself is going to use some of the resources, but your typical SCADA or HMI may have 2 vCPUs, historian 2 vCPUs. That's a standard deployment with 8 gigs of RAM and then a varying disk capacity. In an FT, you may just have your SCADA and HMI with an RDS environment. And that's one thing, haven't really touched on. A great place for this is if you're deploying thin clients at that machine. So say you've got a machine that does just one thing and you need the compute to be monitoring that and you don't want it back in the data center. Well, you can deploy your HMI and remote desktop services or Thin Manager if you go that route, and have anywhere from 5 to 10 thin clients all managed in a redundant and high availability environment very easily. The thing that impressed me the most about this, and I think is one of the biggest draws, is how fast it can be set up. Because it comes out of the box with your virtualization software already on it, you can start installing it, setting it up, configuring it, plugging it in, and building it, and be ready to deploy your virtual machines within 30 minutes of taking it out of the box. And so if you look at your time to deploy in a traditional sense, you can probably have a single or dual node environment up and running with all the applications configured, depending on whether you've got to use ISOs or templates, inside of 4 or 5 hours. And if you look at what your traditional server class or even workstation class deployment is going to be, you're looking at days. So the shortening of your implementation timeline for your customers or if you are the customer, it saves you a lot of man hours and makes it much easier. Now, from a support standpoint, we've got two different levels of support that you can go with. We've got system support, which is a standard, and that gives you software updates and upgrades, root cause problem determination, advanced parts exchange. So when you call us and tell us that it's got an issue, we send you a new node. We don't send a drive or memory or anything like that. It's going to be the entire node, and we give you 24/7 web and phone support and 30-minute response time. The system under system support will phone home locally, so it does have a notification system, whether it is OPC-UA or REST APIs or SNMP traps. You can get local notifications for the system if it has any issues. In the event that it's kind of running headless and you need more support than standard system support, we offer a system health upgrade. And what that provides is 24/7 remote health monitoring and alert triage. And essentially what that means is instead of it phoning home to you, it phones home to us. And we take the notification from the machine, and you just need an outbound only secure communication channel to get out. You can NAT it and put it behind your firewall so it doesn't have to be exposed to the internet. But once we get that notification, we immediately get the correct part or correct node shipped over, and within 2 or 3 days, it goes to wherever it's supposed to go in our system, and you swap it out and send us the other node back. And so it really becomes kind of headless at that point and much easier to deal with. And so that's typically those that need more of an IT assistance. They don't have a lot of IT staff, or they've got the ability to do outbound phone homes. Maybe they need predictive failure analysis and more monitoring of the system. And so a lot of places may need media retention, and media retention is they have to self-destruct the data themselves, so they retain the hard drive if it has a failure. And there's a panel on the back of it to pull that hard drive out, and then you ship us the empty node back, and you can destroy the hard drive as you wish. So those are the two support models that come with the system. They're annual renewals, but they can be anywhere from 1 to 5 year prepay. So you can pay for it up front and use it as a CapEx and handle it that way. Our anticipation for for longevity is approximately 5 years, and so as opposed to your traditional workstation class machines that are running Windows. Once these things are up and running, because it's virtual, you've got a much longer lifespan than is typical, because whether it's a Windows 10 or Windows 2016, our operating system supports that virtualized environment. And that means that as the requirement changes for the applications, as long as there's enough resources, you just spin up a new virtual machine, but you don't have to do a hardware swap out in order to get the new applications deployed. So it makes it much easier to increase the time between those hardware upgrades and optimize your refresh cycles to fit your schedule as opposed to the hardware schedule. And that's pretty much it for ZTC. You know, I wanted to go through. I don't do a ton of slides. I figure Q&A or interaction's better. So if there's any questions at all, feel free to ask them now or during the rest of the seminar. But thanks for the time and appreciate it.
Great, thanks, Muncie. We're actually, before we head into our Q&A session, we're going to finish Rufus's section here. Rufus, I'm passing to you now. We've got all the. Hopefully WebEx doesn't kick you out again.
Yeah, all right, folks. Thanks a lot for your patience. Unfortunately, with technology, WebEx kind of kicked me out. I just literally hung up my phone twice. But anyway, in the interest of time, I'm going to be laser focused, okay? And as systems integrators on the call, I'm going to try to focus on what I believe as systems integrator, what you're most interested in. And so with that in mind, what we're going to do is I'm going to show you 2 different applications. The first application is the an actual running application, right? The key point with this one here is the fact that this will show you all of the bells and the whistles, okay, that comes with, you know, InTouch Edge as far as when you build out an application from, if you're going to use everything. Like, for instance, you can see the animations here on the front screen. Some of the features that come with the software is you get the typical 3D graphics that you would expect to see, all right? You can also use active objects, okay, within your application. If you look at the bottom right, you can see an ActiveX control or a .NET control that, you know, that could be in association with a camera system. What also comes with the software is the capability of creating recipes. You also have the inherent capability to create different types of reports with your application, whether it's in HTML format, RTF or rich text format, CSV, okay, or regular text format. As with any HMI, you would expect to get trending capability, okay? So all of this comes out of the box. Obviously, you get a chance to do alarming capability. Multi-touch multi-touch and gestures give you the ability to utilize the latest hardware, you know, the touchscreen capacity and so forth. Also, this right here shows you all of the different industries that the software can run in, whether it's bioenergy, refinery, you know, anything dealing with ovens, water, wastewater, oil and gas, process control, food and beverage, wind and solar. You essentially, you name it, we are in there. You also get a chance to make the really fancy control screens if you want. The different solutions that you can create with this particular software. For instance, this is an MES or packaging line that you can work with. MES capability, you can create your own MES type systems out of the box. One of the other capabilities that come with the system is you remember the thin clients and such. You can utilize the thin client capability. In this case, this is that same application over a web browser. And as you can see right here, I have the read-write capability. And a little-known tool that some people use, or a little-known capability, is the ability to use language switching. Okay, now this is one of those fully functional applications that takes advantage of the full suite of capabilities that come with the software. So now I'm going to switch it up a little bit, and now I'm going to get really, really simplistic with the application, so I can focus on some of the little known capabilities that come with the application as well. Now, this is the development environment of AVEVA Edge, okay? As you can see right here, it's a modern application or modern application development environment utilizing the Windows ribbon. Each one of these menu options here focuses on specific functions that you can do within the application itself. Down here underneath the Project Explorer, each one of these tabs allows you to focus in on specific aspects of the software as well. For instance, right here under drivers, this gives us the ability to add communications to our software or to our application. As you can see here, as I mentioned before, all of this is out of the box, all of these different drivers. And underneath here, you see I've selected two types of drivers. One is, I'd say, legacy or mainstream, where people, you know, we all understand what Modbus is. So this, in this case right here, this is Modbus TCP, and the one on the bottom is MQTT. And this takes advantage of the latest protocols for IoT. And I'm going to show you how easy it is to configure it. Under Modbus TCP, we do things in something called a driver sheet. Here we have the tags that you would expect, the human readable tags. Over here is the station ID, where you have the IP address, the port number. In this case, I said, as opposed to the standard 502, I said 5020. And you also have the device ID and the address, the IO addresses that will come from your controller. In this case, this will be the holding registers for a Modbus TCP type controller. Now, underneath here, we have MQTT. With MQTT, as Ted pointed out when he was talking through his presentation, we have something called the three components of the MQTT. We have a publisher, a broker, and a subscriber. In this case, we are subscribers. So I am subscribing to this particular broker at this particular address, and I'm subscribing to these topics, and I'm storing the information in some human readable form where I can deal with it, like temperature, pressure, light intensity, humidity, and so forth. Now, one thing I want to focus your attention on, is the ability that we have to, let's say, for instance, to email notifications out. Now, how interesting and how good that would be to have an application where I don't have to buy another piece of software to provide me with text notifications. In this case right here, you can see that I have it set up to go to Gmail, all right? I'm going to log in as a specific user, in this case, Rufus Handsome Demo, and I'm going to send information out. Now, using this particular type of configuration, I can actually set up alarms, and let's do that right quick. I have one here called environmental alarms. Now, I put in one tag, okay, but let's say, for instance, I don't really want to type in a whole bunch. So no problem. I'll just simply go here to a CSV file using any type of text editor, copy the information, and paste it. With that text editor, it's essentially bringing in the top column, and that's something I don't need. I'll get rid of that, and I'll go back to it and just get the additional information. The idea here is that it will decrease your development time just using simple, copy and paste. So I'll come over here to the alarm limits, copy and paste. Get rid of this particular section here, delete the line. And for right now, I won't have any messages. Now, if I go under email settings, I can set it up to send me a text message or an email message when something is in alarm. I just kind of wanted to point that out to you. One of the other features of the software is redundancy, different types of redundancy. Here, I can actually set up a redundant database. Meaning I can pull information from a database, or I can send information to a database. And by setting it up for having a secondary database, I can set that database to be a redundant database. Now, one of the other areas of redundancy that we might want to focus on is this idea of application redundancy. And we can do that with our thin clients, particularly the web thin client. By setting up the web thin client, I can set up a redundant data server IP address. Well, what is that? That is essentially another server that's on the network that can provide data to my thin client app, my web browser, if you will, in the event that one system goes down. So this is a simplified way of doing application redundancy. Sometimes we may want to connect to a third-party database, let's say, for instance, an ERP system, or one of the customer's maintenance databases or something like that. This is my way of selecting or connecting to a third-party database to pull data in, okay, from that database, or send information to that third-party database. Maybe I'm working with another recipe management system or something like that. This right here is a connection to a MySQL database. Okay, if you remember the graphic that I showed, that you were able to connect to all different types of external databases. One would be Microsoft SQL Server. In this case right here, this is MySQL. I just want to kind of show you that flexibility. And how easy to get that information into the system? Well, not a problem. Just create a screen, put a graphic, a symbol on the screen. In this case, it's a grid. Tell it that my data source is coming from a database. And tell me the columns. That's it. Simple. Now, sometimes we do have customers that have legacy type applications, like, for instance, Rockwell panel views and so forth. We do have the ability to bring information in from those other systems as well. Like, for instance, we can use this import wizard. Close these windows. We can use this import wizard to bring information in from those Rockwell-based systems. In this case, I could bring information in from a panel builder, panel mate, an InTouch Edge, another InTouch Edge device, which is an XML screen, and also a factory talk type system. So we can bring that information in as well. Now, sometimes we also we want to bring in tag information from the PLC. Not a problem. We go to our options, go down to communications, and we can come down to this tag integration type capability, select it, and it will ask you the question, well, what provider? Where is it coming from? In this case, we could bring it in from an Allen Bradley RS Logix 5000 family type system. Just simply select add and says, well, where is that L5K file? Browse to the L5K file and you'll bring in your tags for your project, greatly decreasing your development time. A big boost. Sometimes we run into problems with our application and we need ways to, troubleshoot our system. These are two diagnostic screens that you could utilize. This database spy will allow you to pull information in without having to go to your HMI screens. Okay, I'll just simply go to runtime. This is a very, very, very simplistic application that I put together. But what I want to do is go back to my database spy and actually see the information as it comes in. This is how I can see the data. This is the current value of the data. And this right here, this particular screen is the actual output. I can actually set this up to do diagnostics. I can see if I'm actually writing to the field, okay, or reading from the field. I can check my OPC connections to see if the data is coming in, any TCP/IP messages and such. Now, let's say we've got our application, but we need to store this information in some type of database for trending purposes. Not a problem. With the software, we can actually set it up to where we can actually trend the information. Let's say you go here to task and we just simply create a trend. We can trend this information to 3 different sources. Well, we can go to proprietary database, which is native to AVEVA Edge. We can send that information to a third-party database, maybe MySQL, Microsoft SQL, or some other database that supports ODBC, or a Wonderware historian. When we select the Wonderware historian, we also have different choices for that as well. An on-premise historian, we can send information to AVEVA Insight, which is in the cloud. Kevin showed you some of that information, or showed you the interface of AVEVA Insight in the cloud during his presentation. And we can send information to the cloud through CSV or JSON. Now, in my demonstration, I'm sending it to an on-premise Wonderware historian. To set it up was really, really easy, okay? All I had to do is put in the IP address, the user information, and just simply say, okay, then the information gets stored. Now, once the information is stored, not a problem. I can just simply go here to utilize the on-site Insight, the Wonderware historian on-premise Insight utilities, sign in. It'll connect directly to my my Wonderware historian, and all I have to do is start typing to get the information in there. This is information that is coming directly from my AVEVA Edge. Now, this same information can also be sent into the cloud, as I want to point it out, and it's really, really easy to set up. As you can see, I get some of the same capabilities of AVEVA Insight online, but not as much, not the OEE capability that Kevin showed, but this is just the on-premise version where I can get trending information. I can see that the numbers are trending up or trending down. If I actually want to see the trend itself, not a problem. I pull up the actual trend, and I get some of the same capabilities. Now, in terms of graphics, creating graphics and such is not a problem. Just right-click, click on Insert, create your new screen. And just simply go over to our symbols over here. And I get a listing of all of the symbols that I can incorporate within my graphics. Now, I also want to point out that the new latest version of the software will be released soon, and it will be able to incorporate the industrial graphics, okay, that what we all know and love. Basically what we used to call the orchestra graphics, the nice 3D symbols as well. Now, one thing that I also want to point out is the capability to expand your application using ActiveX controls or .NET controls. Again, you remember that screen, that PowerPoint slide that says there's a lot of, okay. Also, I need to wrap this up. So but basically the ActiveX control and the .NET control is a way to expand your system. All right, there's a lot more capability with the software, but in the interest of time, I'm going to wrap this up, okay, and give time for questions and answers. Okay, I'll turn it back over to you, Katie. Thank you.
Great, thanks, Rufus. I'm switching here now. Thank you all. I'm going to release our poll. So if you wouldn't mind answering our quick poll while we collect your questions, we would greatly appreciate that. I'm just going to make sure I've got my boxes here. And we do have quite a few questions that have come in, so I would like to ask those. And please feel free to add more to your to the Q&A or chat box. So while we're doing the poll, I'm going to start with some questions. Kevin, I believe this is for you. How hard is it to implement EXO downtime?
Great question. So depends which side of the fence you're standing on, I suppose. So it's not hard. So the configuring the cloud environment is pretty straightforward. Some of that is done, you know, in real time from the web, and some of it is done using CSV files as a proxy for uploading data. But the real beauty of our XO solutions is that all that's abstracted from the end user, and so we take care of all that for them. Obviously, they need to help us understand their automation infrastructure if we're leveraging that, but it's a really straightforward implementation. And in fact, most of our implementations take only a few days of customer site time.
Okay, great. And then this is also a question for you. Can I see the cloud data on my phone?
Yes, I should have mentioned that. There are apps for both iOS and Android.
Great. Muncie, this is for you. How far can the system be expanded? Oh, wait a minute. Let me unmute you. All right, sorry. Apparently, I don't know how to run my own WebEx. Oh, no.
There we go.
Yep, there you go. You're good.
Okay. So let me make sure I understand. Are we asking how far apart the two nodes can be, or what's the expansion capabilities from a resource standpoint?
I believe this is related to the resource standpoint. They were talking. This question came in while you were talking about the resources.
Gotcha. So the system is fully sealed and hardened, and so the way it comes is the way it comes. So you've got up to 12 vCPUs to allocate, and then up to 32 or 64 gigs, depending on model, and then 5 to 12, half a terabyte to 2 terabytes of storage. So once you've allocated what's there, it's done. So there's no really expansion of the box itself. So we've got a sizing tool that we use to help gauge how big do you need to buy before you do. And so we try to make sure that you size it right the first time instead of needing to go back and do it later. And it is a I guess it comes in a pair. You don't do multiple, like 3 or more nodes. It is a one-to-one type of relationship. Does that answer?
I believe so. Great. So Rufus, these next few are for you. You mentioned the ability to import Rockwell panel meet or panel view applications. How does that work, and how much of the application is imported? Graphics, IO, scripting, etc.
Well, with anything, it's a good question. As far as how does it work, for those individuals that require a little bit of assistance, we do actually provide a couple of PDF documents that will step you through the process step by step. And as far as the importation of the projects, I'd say a good 80 to 90%. It's not 100% because there are little things that may not make it in there. but generally between, I'd say 80 to 90% of the actual application is imported in, depending on how complex the application is. But again, we do have PDF documentation that we could send to whatever customer requires it, that will step you through the process, step by step.
Great. This is also about InTouch Edge. Can I display an InTouch Edge screen inside my InTouch screens via a web browser?
Yes, InTouch actually has something called a web container. And through, the screens that I showed earlier with the SMA and the web thin client, it's just a web browser. As long as you have a URL and you have access to the system, you can display it inside of in a web container within InTouch.
Okay. And then does the HTML5 version of the Edge HMI support both read and write?
Yes, it does.
Let me see here. That looks to be all our questions at this point. I would like to thank you all for your time today. Thank you to our presenters, and we look forward to seeing you next week. If you have any further questions or would like to learn more, please don't hesitate to contact us. You can reach us through our email address at communications@insourcess.com or our website at insource.solutions. Once again, thank you so much, and we'll see you next week.